So this lecture and the next lecture, I will be explaining two great articles from Google Brain and Google Research that use how to do reasoning, which is the third faculty of Kant, Immanuel Kant, if you like philosophy, using large language models, but we use chain of thought prompting because traditional prompting is very naive, and you could see that in ChatGPT less than 3, but modern ChatGPT uses chain of thought. So this is very important to use chain of thought prompting in order to generalize better with less unsupervised data and better, because sometimes there is a spurious correlation if you just use prompting. But if you use chain of thought that I'm gonna explain it now, it would be much better. So this article is about chain of thought prompting, elicits reasoning. But in the next lecture I will explain lambda, which is a really interesting article. So although there are other important articles, you know that language models are like future learners because just a few examples is enough for them in order to generalize well. Of course, the idea of future learning, I have a playlist for this, future learning. You know that the original idea comes from computer vision, but you see that how well this article relates it to future learning. And also there is another article, tree of thoughts, which is, for example, you score, because it's like breadth first search or depth first search. You score different path reasoning. You come back if if it doesn't have a good score, come back and you see which path would be a good reasoning path, good chain of thoughts, let's say. So what is the idea? We explore how generating a chain of thought, which is a series of, I always say the Markov human mind is a Markov chain, make it ergodic, because I said this sentence exactly 2 years ago because I was working on Markov chains. You go from one thought to another thought, then it triggers another thought. Then, for example, if you think about Putin, you think about, for example, what is the value of why there is a war in this planet and why there are some people. So you go from one thought to another thought until you arrive at a distribution. You converge at a distribution in this Markov chain of thoughts. And this is very important from cognitive perspective and also from applied artificial intelligence. So it's very important to know. We show how such reasoning abilities emerge naturally in sufficiently large language models via a simple method called a chain of thought prompting, where a few chain of thought demonstrations are provided as exemplars in prompting. So the standard prompting is very naive. So it provides very spurious results, so the answer is not reliable. But if you use chain of thought prompting, you can know how step-by-step reasoning of that, which is very natural to what human brain does. At each step you understand it, and that's why these are very good features as well, because it generalizes well. You know how you arrive, and you can debug it. For example, you can say, okay, this argument is wrong until this argument is correct, but after this argument there is a problem, we should resolve it. So you can also do some kind of debugging, which is really interesting. So what are the inspirational roots of the idea? Techniques for arithmetic reasoning can benefit from generating natural language rationales that leads to the final answer. Prior work has given models the ability to generate natural language intermediate steps by training from scratch or fine-tuning a pre-trained model. In addition to neurosymbolic methods that use formal languages instead of natural language, large language models offer the exciting prospect of in-context future learning via prompting. That is, instead of fine-tuning a separate language model checkpoint, we are tired of creating checkpoint for each new task. So why not simply prompt the model with a few input-output exemplars demonstrating the task? What is a chain of thought? Triples. Input, chain of thought, output. So a chain of thought is a series of intermediate natural language reasoning steps that leads to the final output. And we refer to this approach as chain of thought prompting. So this is a standard prompting. We don't like it. It's very naive. But nowadays, in 2023, we do like this. We say that, for example, Roger has 5 tennis balls. So Roger started with 5 balls, 2 cans of 3 tennis balls. So we speak our thoughts. So is 6 10 balls, and then we add it. So we combine that semantic parser with this natural language. So it becomes very powerful. So it's not only a good understanding, but also can do, because when we do logical reasoning, we don't need lots of training data. Few-shot learning and zero-shot learning is enough. We don't need lots of training data. And it's very weird if we use that, because a child needs just a few examples in order to generalize well. So what is a data set? You know that GSM 8K is mass word problems, and the solve rate of that, of this chain of thought prompting, the idea of this paper, you see it is around 57%, which is much better than your naive 18%, which is standard. This is a standard prompting. As I said, this is naive, but the 57%, this one is the idea of this paper. So it is typical to decompose the problem into intermediate steps and solve each problem before giving the final answer. After Jane gives 2 flowers to her mom, she has 10. Then she gives 3 to her dad, she will have 7, so the answer is 7. The goal of this paper is to endow language models with the ability to generate similar chain of thought, a coherent series of intermediate reasoning steps that leads to the final answer for a problem. Attractive properties of chain of thought reasoning. First, chain of thought in principle allows models to decompose a multi-step problems into intermediate steps, which means that additional computation can be allocated problems that require more reasoning steps. Second, a chain of thought provides an interpretable window into behavior of the model, suggesting how it might have arrived at a particular answer and providing opportunities. Third, chain of thought reasoning can be used for tasks such as math, word problems, common sense reasoning, and symbolic manipulation, and is potentially applicable to any task that humans can solve via language. And finally, chain of thought reasoning can be readily elicited in sufficiently large off-the-shelf language models simply by including examples of chain of thought. So the system is the same, just we include some example of chain of thought sequences. For example, there are 17 trees originally. This is the kind of raising that we do. Then there were 21 after some were planted. So there must have been 6. So you see how interesting it is. But there are also other types of questions as well, like this one, algebraic word problems. So if 10 is added to each number, then the mean of numbers is also increases by 10. So the new mean would be 50. Or you can use it for example, I ask ChatGPT 4, take the last letters of, for example, my name, Farshad Noravich, and concatenate it. So it became DH, so it was correct, although it didn't train on my name. So it means that it is doing some kind of reasoning rather than just memorizing. And this is because it involves the chains of, it is using and leveraging the chain of thought reasoning. So prompt for coin flip as another interesting example. So it says the coin was flipped. So the coin was flipped 2 times, which is even number. The coin started heads up, so after an even numbers, so even numbers is here, it will still be heads up. So you see, it's very natural. It's like human brain. And or another interesting example, the answer must be an item that can absorb ink. Of the above choices, only blotters are used to absorb ink.